We are now ready to correct the on your own problems on page 27. Let's take a look at number 5. The number we need to do the prime factorization for is 20. Now there are different ways that you can multiply to get 20, but I started off with 4 times 5. Now, when I keep moving on, 5 I know is prime, so it is done, but 4 is composite, so I needed to keep going to 2 times 2. Now, I would recommend, and I'll try to do this on the computer, I would recommend that when you get to the prime number, circle it. I did not, simply because using the computer mouse can get pretty difficult. But once you are done with the prime factorization, you should have gotten 2 times 2 times 5. Even if you did 2 times 10 up here instead of 4 and 5 for your factors, in the end you would still get the same answer. So when I would write out the prime factorization here, I would have 2 times 2 times 5 for my final answer. Okay, taking a look at number 6, 88. I chose to use the factors 8 times 11. 11 is prime, so I stopped. 8 is composite, I kept going, and then multiplied 2 times 4 to get 8. I can then stop with the 2, but 4 is composite. I kept going until I got the 2 factors, 2 times 2. So down here, my final answer for the prime factorization of 88 is 2 times 2 times 2 times 11. Now, one thing I want to point out is the prime factorization for all numbers is unique to that number. There is no other number, for example, number 20, the prime factorization is 2 times 2 times 5. There is no other number that has that same set of numbers for the prime factorization. They are all unique to that number. Same for 88, 2 times 2 times 2 times 11. There is no other number that has this for the prime factorization. Now, one thing you should also notice is that when you are done and you have your answer, all of the numbers down here are prime. There are no composite numbers at all. Okay, let's take a look at 90. I used 9 times 10, and then I broke it down to the next step to get the prime numbers of 3 times 3 for 9 and 2 times 5 for 10. So in this case, my prime factorization, and remember you go least to greatest, so it would be 2 times 3 times 3, whoops, sorry about that, times 3 times 5. Okay, we're now ready to begin the activities for our page. So the essential question that they want you to discover through these activities is, without dividing, how can you tell when a number is divisible by another number? In activity 1, you are going to go through the steps A, B, C, D, and E, complete them in your workbook by just doing whatever they ask you to do. So for example, A says highlight all the numbers that are divisible by 2. Now, you know if a number is divisible by 2 simply by skip counting. What are all of the multiples of 2? So if I were going to be doing this in my workbook, I know that the first number that I can multiply, 2 times 1 is 2, so I've highlighted it. 2 times 2 is 4, 2 times 3 is 6, and I'm just going to keep going and highlight all of the numbers that are multiples of 2. The next one is the numbers that are divisible by 3, and you need to put a box around it. So you're going to take a look at the number 3, start here. You're going to put a box around the number 3. Okay, that's 3 times 1. And then you're going to go 3 times 2, 3 times 3. Put a box around anything that is a multiple of 3. You're going to do the same thing with the others. And in the end, question E asks you, what patterns do you see? Please write 4 rules to determine when a number is divisible by 2, 3, 5, and 10.